today, this afternoon's one, is speeding up software delivery using Docker continuous delivery pipelines. So the first thing is, if you were expecting a fashion show about Dockers, that's not what we're going to be talking about. Okay, so hopefully you're all staying. You're interested in technology. So a little bit about myself. I'm Nigel Harniman, and I'm a solutions architect for CloudBees. So I'm not sure if any of you have heard of CloudBees, but Kazuki Kawaguchi, who invented Hudson, which became Jenkins, is our CTO. And we really help customers with their Jenkins deployments at scale. Before joining CloudBees, though, I had a fairly big stint as an engineer, been kind of in the industry for about 20+ years. I know, I don't look that old. And I've done kind of things as a developer, as a DevOps, as an architect. And at Sky, I really got into the whole automation and continuous delivery, probably before we kind of coined those phrases. So I've been in the trenches and been doing it. So quick show of hands here. I'm assuming most people are developers. Yep. So how many of you in your role do operations now? Are there any guys from ops or doing operations? OK. And how many of you use Jenkins? Good. Brilliant. And how many of you are using Docker today? OK, fewer hands. And how many of you have got Docker actually in production? Oh, there's a couple of brave people pushing the boundaries. OK. What about doing continuous integration? Who's doing that? OK, fair number. And who's doing continuous delivery? Continuous deployments? Fewer of you. And how many of you want to be doing continuous delivery? OK. And out of that, how many is because your boss has told you? OK, good. So it's an engineer-led movement. Right. OK. So we heard this this morning. Software is eating the world, that quote from Mark Andreessen. But really, we are now seeing that all businesses are defining their products by the software that they add to them. A car is no longer just the mechanics of the car. It has software. I think that's been brought to light recently with a certain car maker who has a software bug to do with emissions. But I heard on the radio yesterday, whilst traveling to the airport, a car advert that was not talking about the car itself, but they were talking about the Bluetooth integration and the ability to wave your hand at the dashboard and it would speak the messages off your phone. So is this a car or is this a text-to-voice reader? But anyway, software is really defining what products are. And a couple of examples, aircraft. This is kind of when the fly-by-wire kind of technology took over 20 years ago. Software update in process. I hope they've tested it. This is the A380. Does that look like an aircraft or a big games console? You can see kind of iPad-type screens everywhere. You can see the keyboard front and center. And actually, the joystick is over to the side. It's kind of less critical. And the same thing is happening with cars. The Tesla. Not only do they have all this great electronics in them, but they can actually push their updates over the air. Now, if only this other car maker had that capability, we'd be seeing less recalls. So software is vitally important. And if it goes wrong, you kind of hit the headlines. So air traffic control issue in the States. We've had some issues in the UK with a certain bank. Doesn't seem to be able to deliver software very reliably. We've also had some air traffic control issues. But it's not always a problem for the customer. I think I'd quite like to have been this customer. I probably wouldn't have wanted to be the CTO explaining to the CFO why he was having to write the large check. So the key thing here is software defines our products, and we are going to need to improve our products by building new features in software. And we're always being asked to do it quicker, hopefully cheaper as well. But those pressures are kind of tantamount on us. So most software is to achieve business goals. Ultimately, the business is paying our wages. I'm hoping that everyone here is probably aligned with their projects are trying to achieve these types of things. So we want to go faster. we want to deliver our software better and quicker. And those are kind of often conflicting objectives. How many of you in the old days used to kind of spend 6 months delivering a new release, and a month of that was kind of regression testing at the end? Yeah? Now, when you start delivering releases weekly, you can't stick a month's testing on the end of a weekly release. So the only way that we can do this is by changing the way we work. Now, everyone talks about DevOps. Personally, I'm going to stick my neck out here and say I think it's a cultural thing, not a physical thing. But ultimately, we need to make development operations work better together to be slicker in terms of getting the products out there to market. And the way we kind of do that, and what I've been doing since about 2008, is what's now called continuous delivery. And how are we going to do that? Well, we need automation. You know, we can't do this month's worth of testing at the end of a weekly release. We've got to automate it and bring the time frame down. And so what we want to do is apply automation techniques across the whole pipeline. So a lot of you put your hands up and doing CI. You know, that's the kind of commit and build on the left-hand side. We now need to apply that same automation all the way through to production. So I asked earlier who wants to do CD. Who has automated their application deployment? You know, copying the WAR file over or whatever. Quite a few of you? Okay. Does it always work? Or do you sometimes have these problems? As you go from dev to QA to staging to production. Is it ringing a bell with everyone? Yeah? And how does this make you feel at the end of the development when you kind of go, here you go, production ops guys, deploy it. You're like, why isn't it working? So why does this happen? Well, typically it's because we're moving the application artifact, the binary, from dev to QA to staging and to prod. But we don't move all the configuration associated with it. How many times have you forgotten to create the directory or given it the correct file permissions or even created the account that the application needs to run under? And so when we get to production, we have a problem. If you're lucky, that problem happens in QA and you've got time to fix it. Release night is never a good time for it to happen. So how are we going to prevent this? You know, we've got all this automation around the application code, but what about the environment it runs in? So how do we take those environment changes, package them up as the single binary, and take it into production? So if you think about how we do stuff typically today, you sit there at your keyboard. I know I would have done writing code. We check it into a source code system, probably using Jenkins, because a lot of you put your hands up to build it. We produce a WAR file, and then we hand it over, and we hope that some guys have built the infrastructure to our specification, maybe using Puppet, Ansible, Chef. We fire it up, and we get somebody to test it. And it doesn't work. And that person comes back to the developer and kind of has a few words. And you're sitting there going, well, it worked in dev. So what can we do with Docker? Well, we're writing the code, but we're also writing the configuration. We put it into source, we build it, we produce this big image. So we're now taking the concept of single binary beyond the application and up to the whole sort of stack that's needed for that application. We deploy it, they do some testing, everyone's happy, and you guys take the afternoon off. Seriously, you'll probably end up getting through the feature backlog and building something more useful with your time, or working on a pet project. So just to kind of set the scene with Docker, it's one of a number of container technologies. And really what we're looking at here is a way of virtualizing the OS, mainly on Linux. I know Docker and Windows is kind of being talked about. But really we're talking about on a Linux control host having multiple operating systems running, but without having to have the overhead that you get with virtual machines. And so what we can do is we can package up that whole OS stack as the deployable image. And then we can move that whole image from dev to QA to staging to prod. You know, hopefully everything's happy. So the only thing that should differ is like your underlying host connectivity, like its IP addresses and things like that. That's the theory. So how are we going to build these Docker images? By hand? That's kind of a bit 1990s, isn't it? So we need to automate that. And this is where Jenkins works well with Docker. And so we'll get into the meat of the topic. How can we do that? So there's two ways that Jenkins and Docker work nicely together. The first is we can actually run the Jenkins components within Docker. So your masters, your slaves, if you're running the CloudBees platform, the operations center, can all be run within slaves and spun up very quickly. The second way is to have Docker images actually built by Jenkins. So we'll actually use Jenkins to drive the build, test, publish, deploy cycle. So let's have a look at these in more detail. I do apologize, I'm not doing live demos because pushing Docker images takes a lot of bandwidth and the Wi-Fi here is, anyway, you guys have got beer to go to, so we don't want to do that. So I'm going to do a lot of it as cut and paste configuration on screen. So the first thing is if you want to run the Jenkins components inside Docker, we've got some standard images, and we've got the Docker slaves plugin. We've also got a plugin that allows you to spin up a container just for a build step. And we'll talk about that in a bit. And if you're running the CloudBees version, we can distribute that configuration across the whole cluster from a single place. So the images. If you go to DockerHub _Jenkins, you can find the official images of the open source master. And if you've got the CloudBees versions, the CloudBees master and the operations center are there as well. And if you Google around, there's an awful lot of community slaves images around, so that bundle different build tools depending on what you're looking for. The one I tend to use a lot is Docker in Docker, and you'll see that in a minute. The custom build environment plugin, this enables you to have a reproducible environment. So say you need to guarantee that your build runs with a certain set of OS libraries, OS package versions. So it's almost like a clean room type environment, if you so to speak. And it also means that your builds can be very isolated. You can guarantee no external influences or interference. And of course, with Docker, it's faster than launching a VM from scratch. Even if you've got VM snapshots and you power them up, it takes a few seconds. And when we're talking about trying to reduce time to market, feedback loops, anything that speeds that up is great. And it's really super easy to configure. It also mounts through the volume from the slave, so you can kind of share the workspace, share the tools, and all those sorts of things. And if you have a Docker host that is secured, it fits with the Jenkins Credentials API, you can totally secure it. So you can see up there the bit I've highlighted. When you create a build step, you just create a build inside container, give it the container image that you want to spin up, and that's it. You're kind of done. And it will delegate it to that container. So the next thing is if you've got the CloudBees version managing a whole load of stuff, we can push out the Docker host configuration and all of the slave labels that you're using. And we support Docker Swarm as well. That's that. So now on to kind of the meat, really, of how we do continuous delivery. So to build and test Docker images, CloudBees actually created them, but we kind of pushed them back to the community as open source. We built these plugins called Build and Publish, which actually does the heavy lifting of the Build and Publish. It's really wrapping the Docker APIs, but it just makes it simple in Jenkins. Then we added traceability. As you spin up all these containers for testing, you probably want to know what build they came from so that you can troubleshoot and get back to your source code. And then we've also got DockerHub notification, which allows you to trigger downstream jobs when you do a push to a registry. So let's have a look at these in more detail. So the first one, build and publish. So let's think about a typical sort of pipeline. We're going to build and test our application just as maybe a Maven build. We're going to run some unit tests. We're going to produce a binary. Then we want to create the Docker image. So we need a job to do that. So we're going to pull that WAR file that we created. We're going to use the Docker file, run a build, tag it, and push it to a registry. Then we want to use that image, because, hey, it'd be great if we tested it. So we're going to spin that up, and then we will run some tests against it, maybe with Cucumber or whatever test tools you want to use. So let's have a look at the configurations that enable us to do that. So the first one is building the job. This is a regular job. Maven clean package, something that you should all be familiar with if you're using Jenkins. And we're going to publish the artifacts to the job itself. We're going to keep them within Jenkins. So we do a post-build action of archive the artifacts. I'm also archiving the Docker file. And the reason I want to do that is because I want to know that that Docker file was the one that was versioned along with the source code that produced the application artifact. I want to keep the two in sync. And so as you can see here, when I run the build, I'll have a couple of artifacts published, the Docker file and the snapshot jar. Nothing kind of innovative there. But the next step, and we'd have a job trigger mechanism, we would run the build and publish Docker image job. So we're going to take that Docker file, we're going to pull down that application artifact, and we're going to configure a build step, which is build and publish. I'm hoping that this is large enough to read. The first thing we do is we say, where are we getting the artifact from? So we're pulling down the Docker file and the jar. And then this is where we do the meat of the Docker piece. So we need to give it a repository name. So you have to name the image that you're going to do. We can apply a tag. Here I've just put a single value in. That's probably not particularly helpful, but you can put the Jenkins environment variables in. So you can use the build number. We need to bind to a Docker host to be able to do the build. And of course, you can see there that we can do that securely by specifying a set of credentials from the internal credentials API. And we need to tell it where to publish. Now, if you leave it blank, by default, it is a DockerHub registry. If you've got an internal one, if you're using Sonatype or something like that to host a registry, you put the values in there and, again, set up the credentials. And then there's a number of options, because this step could be either used to do everything. So you could build it and publish it as one hit. But you can also skip the push. You can skip the build. So if you needed to, you could kind of run this twice with something else in the middle, say doing some testing. But it's really that simple to actually build and publish your Docker image from Jenkins using these new plugins. So when we've run that, we should get our tagged build appearing in DockerHub. OK, so that was build and publish, nice and easy. But we probably want to do something with that image that we've built. We're going to want to spin up some containers, run some of the automated tests that are in this pipeline. And in doing that, we're probably going to want to know which containers we're using which image version. Now, Jenkins has a built-in fingerprinting mechanism, and this has been extended with the Traceability plugin. And so we can do this tracking really easily. And if you then also combine it with artifact fingerprinting, you can chase the WAR file back through the jobs and the source that created it. OK, so when we enable this, each build that we do that's doing the Docker build will fingerprint the image that's been created. And that's kind of internal. That's behind the scenes. You can see it on the job. But we're not going to go trawling that by hand, looking for a SHA hash that matches this. So what we want to do is, in our deployment pipeline, we want to track the use of that image. So every time you create a container, if you stop it, if you start it, you want to report those events back to Jenkins so that it knows what happened with it. And the way to find out the API for this is just look at Docker Traceability/API, and it will give you the full syntax. But effectively, you've got two endpoints. Submit container status, which you can curl really easily, and all you have to do is pass in the output of Docker inspect. So when you spin up a container, grab its ID, call Docker inspect, and pipe it into this API. The other one allows you to build the whole JSON API payload yourself if you want to customize it. So how are we going to use this? Pretty easy. From a shell script. So if I'm running a freestyle job that's going to spin up a container and run some testing, when I do my Docker run command, I'm going to grab the container ID via a temporary file. That seems to be the way Docker wants you to do it. And then I'm just going to curl that endpoint. Now, I may need to curl it with a user and token if it's secured, if you've got a secured Jenkins, but that's super simple. And then you can see there about the it's the second data payload item in. It's just saying inspect data equals, and it's the output of the Docker inspect command. Then I'm telling it that this was a container start. I'm giving it some host information. That's the sort of stuff that your deployment script has got available to it. So after I've done my testing and I do a stop of the container, because clearly I want to save the resources on my build environment, I will then curl again that API, and I will tell it it's stopped. Okay, so super easy to use, and what does that give us? So on the left-hand menu, you'll see a Docker traceability link. You'll get a list of containers that Jenkins knows about, and if we find one of those containers, we can click into it, and we get a load of information about it, including the events that occurred on it, so when it was created, when it was started, when it was stopped. So if your testers are saying it didn't work, at least you can check you're talking about the right version. So if you want to give it environment information and other stuff, you can add that in. And then you've got a link back to the build. And so from there, you've got that traceability. This container wasn't working. Let's trace back. Let's look at the source of the application. Let's look at the source of the Docker file, because maybe that was where the problem was, and let's resolve it. So there's no more guessing about latest and which one we've been using. It also means that if you go back and spin up a container like a week later, you've still got all that traceability. Okay, so DockerHub notification. This is a useful plugin to collaborate between projects or even within your own project. So when I did the Docker push, I could trigger another job to do a set of testing. But I might actually want to say that push event on DockerHub is what's going to trigger that job. Why might I want to do that? I'm assuming that you're not going to take the public, Ubuntu base image into your organizations. Do you trust it? I'm sure that your organizations will create a Docker base image that's hardened, secured, got the monitoring tools on, and got everything else in. And so if you do that, and that's another team that builds that image for your whole organization, every time they push it to your Docker registry, you're probably going to want to trigger your builds to rerun. So even if your application artifact hasn't changed, you'll want to rerun the Docker image creation process and put it through some testing to make sure that what's happened in that upstream OS build hasn't broken your application. And so we can set up this notification really easily. Assuming your Jenkins are secured, which if this is going to be callable from DockerHub on the internet, I hope it is, you'll need to set up a webhook account, which is just a case of setting up a user with the right permissions. Then you need to go to the Docker registry and set up that callback. And I'll show you the screens for that in DockerHub. And then you need to set up your builds to listen for that trigger event. So this is what the webhook setup looks like on DockerHub. If you go to your repository, you'll see a link saying add webhook. And the format is, again, really easy. It's user token at your Jenkins host URL. And then there's just a URL to hit, DockerHub webhook/notify. And you can, certainly on DockerHub, you can add many of those. So if in your organization you've got 10 Jenkins servers and you need to tell all of them that there's been a push event, you can kind of set that up. Then you need to go across to the job. And you'll see a new trigger option. And I can use this in one of two ways. I can either detect automatically when I run a build that I'm using an image. So if I do a container run, that build will know that it referenced that image, and it will log that and tag the build that it knows that. Or, in the case of certainly if your kind of core Ubuntu base is changing, you probably want to list the images that you're interested in getting triggers for. And if one of those events comes in that says one of those images has changed, your build will then get triggered. So super, super easy to set up. Okay, so that's kind of the core plugins used as freestyle jobs. But actually where this gets really interesting is if you combine it with the workflow job type that was launched last year. And so with this, we can actually build an entire pipeline as a single job and take it through all of those build, test kind of steps. So what I'm showing here is actually the visualizer that you get with the CloudBees Jenkins platform, but you can kind of do the same thing with open source. It just doesn't look quite as friendly as this, but you can still do all the stages and set up the pipeline. And so if we actually have a look at this in a bit more detail, and I'll go through some of the code fragments with you, we're going to have a pipeline now that's perhaps a little bit more complex than the first one. So we're still going to build and unit test the app, create a WAR file. We'll run Sonar. Maybe we run some integration testing on the app itself. And we're going to do all of that within a custom build environment, a clean room. We'll then prepare the release. All that does in my example is grabs the version out of the POM. But then we're going to build the Docker image. We're going to tag it. Then we're going to run it up and test it. So I'll show you how you can do that. That will include calling that notify, so we've got the traceability. And then we're going to do the push. OK. So the first step, build and unit test. By the way, how many of you have seen Workflow and how to play with it? Oh, this is all new. OK. The good news for you is I think the slides are going to be circulated, and I've got some links in the back to all the source code, so you can download and have a go with it. So the first thing we'll do is we'll give it a stage name. Remember that visualizer? We want to know where we are going across. We can invent those. They can be whatever you want. Next, we need to allocate a slave to do the build. If you use labels today, that is just a label. So I'm going to pick one of my slaves that I know has Docker actually installed on it, because I'm going to then spin up a container inside for that clean room environment. This is how you do that clean room environment. So you have a block scoping that says, inside that slave, I now want you to create a container from that image reference. I also mount a data volume because, as everyone knows with things like Maven, downloading the repository time and time again is a little bit slow. And so what I tend to do is share a data volume between everything on my host so that I've got a kind of permanent cache. And because I'm now using a set of custom settings, I'm going to write the file out. There's a write file syntax in Workflow, so I'm just going to pump out the values that I need. And this is what's doing the kind of guts of the work here. We're actually saying within that image, I now want you to run the git SCM step. So this is a bit like how you configure a regular build step to do a git checkout. And then I want you to launch Maven with that custom settings file and run a clean package. Okay, so nice simple code that says, build my app. I think this is just showing you where I said I want to use a Docker slave, or a label that is of type Docker. In my environment, this is actually a Docker slave as well. So I'm running Docker inside Docker. Kind of does your head in. But the way you can set this up, if you're running the Docker slaves plugin, you just list the images and the labels that are associated with them, so you can have many different slave types as Docker images and just spin those containers up on demand. So you just give it a template name, give it the label, and then off you go. OK, so within that clean room environment that we were building in, we're then going to run Sonar and integration testing. And again, the workflow syntax is super simple. Give it a stage name so you can track it, and then run another Maven target, not forgetting your settings file. So Maven, Sonar, Sonar. Integration test, we'll give it another stage label so we can see the progress, and then we'll run whatever the Maven target is. In this case, I'm running a verify. And as you can see there, we're archiving the unit test results, so just like you would on a regular Jenkins job. OK, so we've now built our WAR file. We've done a bit of testing on it. We've done some code quality metrics on it. Kind of looks good. So now let's do the heavy lifting of the Docker stuff, actually building the Docker image. So again, pretty simple syntax. We're going to use some block scoping here to say, run all of this within the context of talking to this particular Docker host. OK, so docker.withServer give it the URL to your Docker host or the pipe if you're using it on the same host. You can bind it with credentials, so again, nice and secure, just like I did in the UI. We've got a stage name set up, and then the dir command is just a temporary change directory and change back again. So let's cd to that directory, run some more commands, cd back again. So I'm moving some files around, but really I just want to, my Docker file is sitting in the .docker directory, so I just want to make sure everything's just running within the context of that directory. So we've copied the jar file in, so it's path local, and then we just run docker.build. Give it the repository name, give it the build tag, that's it. That will create our Docker image. Notice that I've grabbed a handle to it. I've grabbed the reference to it because I want to actually use that later on. So how am I going to use it? I'm going to do a run command. I want to spin up a container. I'm going to do some testing. So we give it the name of the container we want to spin up. We give it the port number. You've seen all this from the talks today. Whenever you spin up a Docker container, there's a whole bunch of parameters that you need to give it, and you can just insert those in here. If you want to spin up multiple containers, you can use Kubernetes, or you could put a loop in here and just iterate round. Super simple. And again, I get a reference to the container, because in the next step, I'm going to do that traceability call. I've actually truncated that because it was quite lengthy, but you saw it earlier. I'll just do the shell step to run the curl, give it the container ID. I've now logged the fact that I've created a container from that image. I'll then run some tests, which I haven't got in this particular example because of screen size. And if everything's good, the script carries on. We get another stage called publish the Docker image. And again, really simple syntax. I need to bind myself to a Docker registry. Again, if my registry parameter is blank, that means it's DockerHub, DockerHub's registry. Again, I can bind with credentials. So in this instance, I think that's my DockerHub username password that refers to. And then I do a image push. So in that whole workflow, we've built, we've tested, we've done whatever validation we want to do. We've built a Docker image. We've done some more testing, some more validation. Might be perf testing, could be pen testing. And if all that's successful, we then push the tagged image that can be used either in final manual testing if you've still got it, or pushed to production. And so at the end of all that, we should have a nice tagged image in our registry. So to conclude, what have we actually done? We've tried to build here and been, I think, pretty successful. I might even show you this if the Wi-Fi holds up. Famous last words. What we've actually done is taken your application code. We've taken the upstream Docker images that have been tested within your organization with a Docker file. We've assembled all that together. We've created this super binary of the whole application stack for the application tier itself. We've created that gold image, and then we put it through a number of testing steps. We blessed it, and we said it's good to go. And if you do that with all the automated testing, there's nothing to stop you having to turn that around in kind of hours, or a number of hours in the day if your test cycles run that quick. And so with Jenkins and Docker, you've got a good platform here to build a nice continuous delivery pipeline and be able to sort out that problem of how do I get all the baggage that goes with my application into production. Now I'm going to hold my hand up here and say, you still need to sort out networking. You might need to sort out load balancing. You might need to sort out your data tier. But there are other tools that can help you with that. But at least let's get the application built and tested reliably and deployed reliably. And so to recap on how we did that, it's these 6 plugins that were released earlier this year to the community. So Docker Workflow, Build and Publish, DockerHub Notification, Traceability, the Docker Slaves, and the Custom Build Environment. If you want to get started on this, there weren't many hands went up as far as workflow was concerned. So All the references are on here. How to use Docker with Workflow is the first link. There's a standard tutorial for how to build workflow jobs, which I'd highly recommend you go through. It kind of talks you through all the basic syntax. And if you want to see that mobile API workflow, that's the last bit there. It's on my GitHub. You can download it. You'll have to tweak around sort of the credentials and things, and you should be able to get it working. So I'm going to think we see if we can get that workflow running live. Famous last words. Let's see if the network holds up. So this was the thing that we were building. So we're going to build the app. Oh, nothing there. Let me move it across. I should have spotted that on that monitor. It's running sluggish. Let's have a look in the logs and see what it's doing. Let's go into here. So the other thing with the workflow is it will bring all of those steps, all of the logs will come back into that one job. So when you're trying to diagnose what happened across your whole pipeline, you've actually only got one place that you need to go. So what's that say it's doing? It's trying to run. It's compiling. It's looking a bit slow, isn't it? Oh, no, it's going. So what has that done? Let's have a look on the stage view. Let's zoom it out. OK, so that would run the build. It was running the testing. It's still running some testing. And then we'll move across. Now, with Workflow, if anything fails, you'll get the red bar only going halfway across, and it will tell you that that particular pipeline failed. And we've got some other things in the enterprise version that allow you to resume it and restart and clever bits like that. But this will keep going. Yeah, it's slow. This is why I don't do live demos normally, but as we've kind of had time, I thought we'd add some excitement. OK, when that's done, the next bit, it will be just grabbing the release number. It will be fast, but yeah, something's not happy with this. OK, let's just go back to the presentation. We'll come back to that and see if it's finished by the end. OK, and I've got one more kind of slide, really, which is how do you manage continuous delivery at scale? If you're using Jenkins, you'll find that you can get a long way with it. With Workflow, you can get even further across to the right-hand side. We're building these pipelines. But the challenge is always going to be, as you get towards production, this system is going to become more critical to your organization. We're no longer talking about whether you can be dev complete and go to the pub. We're talking about whether you can actually push the button and do your production release, if you automate everything. And so really, my final slide is to say, if you kind of want to do it at scale, come and have a talk to us, and we'll see how we can help you. And so, final slide, got my contact details. If you've got any questions around how the code works, if you can't get it working, drop me a mail, contact me on Twitter. We've probably got about 10 minutes now for questions. Yes, no? Yeah? Yeah, I think we have. We've got 10 minutes.
After that, your slides will switch for a movie.
Oh, OK. I better duck out of the way quick then.
You have some time left. But
OK. There you go. The pipeline's run. And now it will definitely run slow, because that's now pushing the image up to DockerHub over the Wi-Fi. So that will take quite a long while. But you can see it's kind of running all the way through. And if you build that for all your microservices and start building Docker images, it's in good shape. So we've got time for some questions. Stunned silence. Everyone wants their beer. No? OK.